Hello everyone and welcome to another lecture of School of Solana. It's Adam here and today we will be talking about front-end development for Anchor project. And in today's lecture we will be mostly coding, so it will be a hands-on, and I will show you a brief introduction to front-end on Solana. So obviously this is a completely new topic, and also the front-end development is pretty complex. So as I said, it will be only a brief introduction. But today we will deploy our DApp to DevNet, and for the front-end we will use Solana DApp scaffold project. That is a project in React Next.js, and it will help us to start quickly. And as a demo, we will use our banking app that we have developed in previous lectures. So our front end will use our browser's wallet. So in my case, I'm using Phantom, and we will use our program, or our front end, to interact with our program and create the required PDA accounts. We will create a bank. Then our front end will be able to list all the banks, and also we will add a functionality to deposit some funds to the bank. So every time you click a button, we will deposit 0.1 Solana to a bank account. And the only thing that will not be implemented in our front end today will be the withdraw function, but everything that you will learn today will help you to implement it yourself later on, if you will. So as I said, we will use the Solana scaffold. This is a GitHub project. And basically this project really helps you to start quickly. So most of the important things are already implemented. For example, the wallet adapter is already there, so you don't have to add it manually. So of course you could start from or with a blank project, but our time is limited today, so we will use the scaffold project here. So yeah, I think we can start, and let's jump to the code. Okay, so here I am in my terminal, and first of all we will start by deploying our bank app or bank program to the DevNet. So if you don't have already the program on your computer, you can clone it from our Eki blockchain repo, like that. I will not do that because I already did it before. And yeah, let's open our code editor. And what we are going to do is that we are going to do some settings. So first of all, we can check the anchor.toml settings. So as you can see here, you have the pub keys of our program. So here, this is the pub key of the local net that will be used. And what we are going to do, that we will add also another address for the DevNet. So let's change this local net to DevNet. And also we will change the cluster where we will be deploying, also from localnet to DevNet, like so. And now actually we want to check that this public address, that we have also the key pair for that. So what we can do from the terminal, we can do anchor keys list, and as you can see here, we have the key that is included here in the target folder in the repo. So this is obviously not correct, and the addresses are the pub keys are different, so we will need to generate a new one. And also, if we will check this address on DevNet, there is already a program deployed on this address, so you won't be able to deploy a new version because you won't be the authority. So what we are going to do is that we will simply remove this this key, and this key is stored in the target folder deploy and Solana PDA's keypair.json. So let's just remove it. And now if we call again anchor keys list, it will generate a new key pair for us. And this key pair, or this pub key, will be the address of the program that we will deploy. However, now the public key does not correspond to the addresses here and also in our program itself. But what we can do is to use a command of anchor, which is keys sync, and it just told us that it found incorrect program ID declaration in the lib.rs source file, and it updated it, and also in the anchor toml. So as you can see, the DevNet part already updated to the correct address that we have just generated with anchor keys. So cool, that's done. And now what we can do, we can also change the wallet. So the wallet will be used as the upgrade authority for our program. So either you can use this default wallet, but what I'm going to do is that I'm going to generate the new key pair, and this can be done by a Solana key gen new -o id JSON. So it will generate the new key pair file. So we don't need a passphrase, and yeah, cool. So we have it generated, and we would like to use or we will use this address as deployment authority. But what we need to do is to have some balance. Now we are on DevNet. We have to also verify or set our CLI to use DevNet. So what we can do is type Solana config set URL and D. It stands for DevNet, or you can just write DevNet like so. And now we can verify that our account our authority does not have any balance. So it will be 0. So we need to airdrop some sol for the deployment. So as you already know, one way is to airdrop some sols. So let's do that. And as the airdrop amount is limited, let's try to do 1. And yeah, I cannot do that because I have reached the limit for today. There is also another solution. We can use Solana faucet for that, and for that we will need the pub key of our account. So let's type Solana account id.json. So here is the pub key. It says that there is an error, account not found, because we have generated the key pair only locally, and there is no balance, so the account was not initialized yet, but it will happen once we will airdrop some sols. And so now we have the pub key that I have copied, and we can go to faucet.solana.com, and you can simply paste the key here. You have to choose DevNet and the amount of sols. So I want the maximum here, 5 sols, and click confirm, and it says that it was successful, airdrop successful. Let's verify, and let's type balance ID, and we have 5 sols. So make sure that you will airdrop at least 10 sols, because for the deployment you need actually the double of balance that is actually needed, because you need to the deployment creates a buffer account first. Also there is the default settings that the amount of data is set to double than your actual program in order to account for future updates. So make sure that you have enough sols on your account that will be used as a deploy authority or as the wallet. Yeah, I have used already all the requests, the airdrop requests that I have for today. So I will just transfer it from my other wallet. It's another option, and I will be back soon. So now I already have enough sols on my account for the deployment, so we can proceed. And it should be very easy. It should be as easy as typing anchor deploy. So let's try it. And cool, we are done. Once we have the program deployed, there is one very important file that is generated when you run the anchor build command, and the file is located under the target and IDL folders. It is this JSON, and it is so-called IDL file, where IDL stands for interface description language. And if we will check the outline of this file, you can see that it contains the address of your program, some metadata, and then it contains basically a description of all the instructions that your program has, the accounts, and the types definitions. So for example, if we will go to the first instruction, it is the instruction create. You can see here that there is some discriminator, what are the accounts expected, and so on. And you will use this file during the front-end development, because this file will be loaded by the Anchor client, and it will basically help us and generate the appropriate methods to call and invoke different instructions, and to compose the transactions for you. So I will show you in a few moments. So now we can finally start to work on our front end, and for that we will clone the Solana Labs DApp scaffold repository, and I will clone it to folder bank frontend. So let's do that and change to the directory, and yeah, so we can just open our code editor. And before we start, we also have to install all the dependencies. So I'm using yarn. So you can type yarn install. It should be possible also to use npm package manager. Here we go, and now we can simply run our app by executing yarn run dev. And here you can see in the logs that there is a server that has been started on this address or localhost and port 3000. So let's check it out. And here we go. The app is loaded, and as you can see, you have here a basic template that you can edit and that you can use to kickstart your own front end and your app. Here are some buttons to airdrop. Here we have two pages actually, so there is a home page and there is also the basics page, and here the buttons are disabled yet because the wallet is not connected. So this will be the next step we will do now. I'm using Phantom. Of course there are different wallets that you can use, but you have to first install it to your browser as a browser extension. And in order to use Phantom, make sure that you use the address localhost. At least on my machine this is how it works, and it does not work for some reason with the address 0.0.0.0. So yeah, we can click select wallet, choose Phantom, and as I already signed into my wallet, it connected automatically, and you can see that the buttons here are active now, and you have here some example functionality to sign message, send a transaction, and so on. And before we will be able to use our wallet, we need to do also some additional settings. So if I open my wallet, you can see here that I'm currently in a test mode. To be in a test mode, you can go into settings, then developer settings, and you have to activate here the test mode switch. And now for Solana, you can choose here, in our case, DevNet. So this will activate the DevNet. And also you must make sure that you have some Solana on your account, because otherwise you won't be able to send any transactions. So airdrop at least a few sols. You can actually directly use this button if you didn't reach the limit yet. Okay, so cool. As you can see, I now received one additional sol, and also here is a little settings button in our app where you can choose the DevNet, which is already selected. And now I would like to show you also what are we going to do today. So what will be the result? So we will modify the basics page, so it will look like that. And we will have two buttons, and if you click the fetch banks button, it will fetch the banks that have been created before, and you will have also a deposit button that will be able to deposit additional sols, or 0.1 sol to the bank account. And of course you can create the create bank button to create a new bank. And now we can finally start to modify the scaffold project in order to add a functionality that will interact with our deployed program. We are here in the root folder of the scaffold project, and you can see here that there is the source folder, and there is a views subfolder and basics. So basics and home, these are the two pages that are in our template. And so we will modify the basics. As you can see here, you have the three components that were the three buttons in the basics page. So yeah, let's delete that and let's change the sign message component to bank component. Also here we have to change the imports. And so now the bank component does not exist, so we have to create it, and they are the components are located in the component subdirectory. So in this case we can just copy, for example, the sign message component and rename it to bank, and now we can edit it. So yeah, here we have to change the sign message to bank, and we can also delete the boilerplate here that we will not need right now. And so now we left actually only one button at the page, so we can check how it looks like. And here is the button that is not active because the wallet is not connected. And here in this component we will essentially implement all the functionality in order to interact with our anchor program. And to interact with our anchor program, we will need to use a new library. So let's do that. And this is the anchor library, which is the Coral XYZ anchor. So let's add that using yarn. Yes, we're done. And now we will have to import some of the stuff that we will need. So let's import the program, also the anchor provider, also the web3 utils. BN stands for big number, and then we will also import the set provider, and we will import it from Coral Anchor. Okay, so this is what we will need, and also what we need is the IDL that I was speaking about previously. So there are actually two files. So if we will go back to our banking app, so it's here, we will need this IDL file, and also there is another folder that is called types. If you open it, there is a TypeScript file which basically contains a type helper that will help us in our frontend. So let's copy these two files and paste it into your frontend. So it can be actually anywhere, but for the sake of simplicity, just I will paste it in the components folder. So I have the files here, and now I will also need to import it. So let's do import IDL from, and now we will do like that. And we will also import the types. So let's import the like so. And now we essentially want to make the IDL accessible as TypeScript object. So what we are going to do is that we are going first to stringify the IDL. So let's do JSON, stringify, and IDL, and then we will use this IDL string to parse it back to an IDL object. So let's call just JSON parse IDL string, and also we would like to read the program ID from the IDL. So we will do something like program ID, and then we will do new public key, and we will read it from the IDL. So if you check the IDL file, here the JSON, you can see that there is this address field. So this is what we are going to use. So let's do IDL address, and that way we have our IDL object prepared, and we have also the program ID that we will use later on. And now the first function that we are going to implement will be the get provider. So this will be a function that will return us a provider. This is something, or anchor, an anchor provider. This is something that we will use to interact with our program. So let's do function provider, and we will use a new anchor provider. And here, as you can see, the parameters are the connection. So we would like actually to reuse the connection provided by the wallet. So this is something that we can import from the wallet adapter package. So let's import up here use connection, and so we will type const connection use connection. So this will actually reference and use the connection that you have set in your wallet in the browser. So connection. Then the next parameter is the wallet. So we are going to use again the wallet. So we will use here the use wallet function, and let's call it our wallet, for example, like so. And then we have some optional parameters here that will tell to our provider, for example, what should be the confirmation status of the transactions and so on. And we can use here anchor provider and default options. Finally, we will call the set provider function and return the provider. And like so, let's put the connection into braces, and we are done with the get provider function. The next thing that we are going to do is to implement a wrapper function, basically, that will call or represent the function of our programs, or inside our on-chain program. So let's start by creating a function that will be called create bank, and this will be the function that we will use in order to invoke the create instruction of our bank program. And to do that, so we will use the try and catch block in order to catch any kind of error. So in case of error, we will just write it to the console that there was an error. So let's write here error while creating a bank, and let's write the error to the console. First of all, we will get the provider that we will use for the connection. So we will use our function that we wrote just before, and now we will create a new program. The program essentially provides a convenient API for you to access the program's methods, and also the accounts, and provides convenient methods to deserialize the data from the program and so on. What we will need here is to supply and provide the IDL object here as the first parameter, and then the provider. So this is what we have. If you just open here the program class, you can go to the source file where you have some nice description. So it says that it provides the ideal deserialized client representation of an anchor program, and it is basically a one-stop shop for all things related to communicating with your program. And the very nice thing is that it provides a set of dynamically generated properties, that really maps one-to-one to your program methods and accounts, which I will show you later on, so you don't have to do it manually. And so now, in order to invoke the create instruction of the bank program, we can just type await. So it is an asynchronous method, and then it will be program, and then here you have the methods, and as you can see, it automatically generated these three fields. Create, deposit, and withdraw. So we can just here have create, and now we will just pass the name of the new bank. So it will be new bank. It is a string. And then the next thing is that we need to provide the accounts that should be included in the transaction. So accounts, and here is new things with new versions of Anchor. And this is that, as you can see here in the tooltip, that there are some resolved accounts that the program class actually is smart enough to resolve some of the accounts for you. So what does it mean? If we will go back to our banking app, let's go to the library.rs. Here we have our create instruction and the context create. So if we will check the context, we will see the three accounts that we will need to supply. So the first one, it is a PDA account, and it is basically something that depends on the user, but it is a constant address, so it cannot be anything. It must have all the time this format and the seeds. Then there is the user, which can be arbitrary, and finally there is the system program. So what does it mean for us? If we will go back to our front end, where we can open the IDL, you can see here that we have here the accounts. So these are the accounts of the create instruction. So here the first account is the bank account, where the seeds are described, how it should be calculated. Then there is the user, and finally there is the system program. And Anchor is smart enough that it will basically recognize that it only needs this the user account in order to calculate the bank account, and the system program is it is a constant, so it can also provide it automatically. So basically the only account that you have to provide here is the user account, and you don't have to supply the other accounts because it's done automatically. And in this case, what we will use is that we will use the Anchor provider public key. So this is the wallet public key, and that's it. We can just only call RPC in order to send the transaction. And finally we could just write some message to the console. So let's write, for example, wow, new bank was created. And if for some reason you would like to supply all the accounts, for example, you would like to use older Anchor versions, or maybe for some testing purposes, it is possible. So let's quickly check how it could be done. So with newer Anchor, what you can use instead of the accounts method, you can use the accounts strict method, and this method will require you to supply all the accounts. So the first one is the bank account, and as we have seen before, so this is the PDA account, so we will have to calculate the address. So let's do const bank and let's say public key find address sync, and now we have to supply an array of the seeds. So the first one, we can use utils bytes UTF-8 encode, and the seed is bank account. This is the first one, and then we have to supply also the user pub key. So this is the Anchor provider pub key, and finally the program ID. And yeah, so to buffer. So yeah, so now we have calculated the address of the bank. So we can directly use it. Then we have the user. It will be the same as in the previous example. And finally, we have the system program where we can use the Web3 system program and program ID. And then finally, just call the RPC method to send the transaction. So this is how it would look like with either older anchor or with this strict account strict method, where you have to supply all the accounts that the transaction is or the instruction of your program is expecting. Yeah, so this is just to show you how it would be done. We don't really need that, so we can delete it for now. The next function we will implement will be the getBanks function, and this function will basically fetch information about all the accounts created by our program in order to display it in our front end. So let's just copy the createBank function and rename it to getBanks, and we can also remove here the call to the createBank function instruction, and let's handle here the error. So it will be error while getting banks. And now we have the same structure. So we have the try and catch block. We get our provider, and we create the client for our program. And now what we want to do is to get the account. So we can use the await connection and get parsed program accounts. So this will get an array of all the accounts that are associated with the given program ID. So it will be our program, and once we will get these accounts, we can just map it, and we will use another async function that will map the accounts that we retrieve from our program, and it will create a new object. And what we are going to do is that we will basically fetch information about the given bank. So we will do await program accounts account and bank, and we will fetch the account. So for that we need again the pub key of the given bank, and also we will return the pub key of the bank, like that, within the object, like so. And because we want to await all the promises, so we will call here, we will wrap it into promise all. Okay, it's pub key, like that. Yeah. And once all the promises are finished, then we can call the then, and banks and we can let's say display the or log the banks to the console, something like that. But also we would like to show it in our front end. So what we are going to do is that we will use, or we will create a new state, and we are going to import the use state from React, and here we can do const banks and set banks use state, and it will be an array like so. And now we can just call here set banks, and that's it. And finally we will implement the last function, and it will be the deposit function, because we need to have a way how to deposit some sols or lamports to our bank account. Again, we can the process will be extremely similar, so we can just copy the create bank function and delete here the RPC call. I will just rename the function name, so let's deposit bank, for example, and like so. And now in this case we will need also the public key of the bank where we would like to deposit. So let's add a parameter here to the function. And now the process is like before. We can simply call the await program methods, and we have here our deposit method. In this case the argument will be the amount of lamports, so beware, it's not the amount in Solana, but it's the amount in lamports, and it is also unsigned 64 integer. So for that we need to use a big number, so this is done like so, new bn. So this is what we have imported here at the very beginning from the Anchor library. So let's go ahead and do new big number, and let's say that we would like to import 0.1 Solana, and we would like to convert it to lamports. So we have to either do it manually, or what we can do, we can just multiply it by web3, and here is the constant lamports per sol. So this will get us the amount, and finally we only need to specify the accounts. Like so, and this will be the same as before, so it will be the end provider public key, and finally we just call the RPC method. And after the deposit we can just write something to the console, which could be deposit done. And also here to the accounts we have to add the bank, which corresponds to the public key parameter that we pass to the function here. So now that we are done with our functions, the last thing that we have to do is to adapt our user interface. So let's go down here to the return statement, and we can modify the button that we have here. So we can just delete this part, and here we will call the create bank function. Also, we will change the caption on the label of the button, so it will be create bank. So this will be one button, and let's do another button to fetch the banks. So this will be get banks, and yeah, let's call it fetch banks. Okay, let's look how it looks like. And yeah, as you can see here, we have the two buttons. So now the final thing that we have to do is to display the banks. So we know that all the data about the banks are in our banks state here that we have created, and the state is essentially an array. So what we have to do is to iterate over the banks within this array and display it in our UI. So what we will do, we will wrap this div in another division like that, and we will add here banks map. So we will just map each individual bank. So the bank, and for each bank we will return the information about the bank. So I have already prepared some styling that we will need here. Like that, and we can display, for example, a name. And actually the bank object now contains the fields that are available in our Solana program, what we have defined. So we have the name, we have to also convert it to string. Then we can, for example, display the balance. So we will also convert it to string. And what we want to do also, we want to add a button that will allow us to deposit some amount to the given bank. So I have prepared the button here. So it is basically the same what we have below. So it says that you will deposit 0.1 Solana, and if you click on it, it will call the deposit bank function that we have here above, and as a parameter it will pass the bank pub key in order to deposit to the given bank. And that's essentially all that we have. So let's quickly recap what we have done so far. So we are using the Anchor library in order to access our Anchor program, and for that also we are using the IDL file here that we are basically first stringifying and then parsing to an object. We are also using the wallet from the browser, using the wallet adapter, and then the associated connection that is set in the wallet in your browser. We have also set up the Anchor provider here with the get provider function that will allow you to use the connection from the browser and the wallet and access your program via this provider. And finally, we have created three functions. One of them is the create bank, where we first get the provider. We create a program that is basically an API in order to invoke the methods from your program that you would like to use. And here we are then invoking the create function in order to create a new bank. And then we have the other functions. So the get banks function that will basically first fetch or get all the accounts associated with your program ID, and it will map all these accounts to a new array of objects that contain the fetched data about the bank and the pub key of the given bank, and it will then update the bank's state that is used in the UI later on. And the last function is here the deposit bank that just deposits 0.1 Solana to the bank account. Okay, and here lastly we have updated the UI, so we just added two buttons, one for creating a bank and the other one to fetch the information about the created banks. And finally here we iterate over the bank's state in order to display the name, the balance, and the deposit button. Alright, so this is the recap, and now let's check how the app actually looks like. So this is how our app looks like. We have two buttons, one to create a bank, the other one to fetch banks. We didn't create a bank yet, so there are no banks displayed right now. So let's go ahead and create a bank. Now we have to interact with our wallet, and we have to confirm the transaction. So let's do that. And now the new bank should be created, and we can you can check it also in the console, or we can just click the fetch banks. And as you can see, there is the new bank with the balance 0 sols or lamports. So now let's try to deposit 0.1 sol. So let's click the button. Confirm. And now if we fetch the banks again, you can see that we have 0.1 sols in lamports. Okay, cool. So one final thing that I would like to show you is that now if we will switch accounts in the wallet, so I have here created another test wallet where I have 1 Solana right now. So what I can do, I can create a new bank. Let's confirm. Fetch banks. And voila, I have here a new bank with 0 balance. And what I can even do is I can deposit 0 0.1 sol, for example, to the first bank of the other owner. So let's do it. Confirm. And if we fetch the banks, now the very first bank has 0 0.2 sols as a balance. So yeah, this is a very nice way how you can create a front end for your app. Also, you can basically deploy your app to DevNet. Then you can publish your front end to some hosting provider, and you can ask potential users or some testers to test your app via your front end. That's it for today. I hope that you have learned how you can use Solana scaffold project in order to kickstart your project, and how you can use also the Anchor client in order to interact with your program. And yeah, thank you for attending today's lecture, and see you next time.